Okay, here in 9.6, what's happening is they're extending things into 3 space. Instead of just I and j, we're going to have an ijk component. And what you'll realize is much of the work that we're doing is exactly the same as the work that we were doing before. And so I'll work a few problems with you, and you'll see how those work. Um, but it's all a natural extension. There is some problems a little bit later on where we have to go and find a vector that's orthogonal to others, and that's found through the cross product, but they're holding that off to section 9.7. And so let's see what they're asking us to do as we get going in 9.6. One of the questions that they're asking is one like 9.6 number 20. That's right up in the front. And what they're giving us is a P1, and they're defining P1 to be the initial point, and that's the initial point negative 2, 2, negative 3, negative 3. And then a P2, which is the terminal point, and that is 4, 1, 1. 4, 1, negative 1 to get it copied correctly. So those are the numbers there. And what they want is the distance between those points. Well, what they show us is that the distance formula naturally extends to the difference of the x's squared plus the distance between the y's squared. That's what it used to be, but we can add the z component as well. Make that a 1 there. And so we're just following that regular distance formula. So they just want us to know that things naturally extend. And so this would be like our new r, right? The distance between, or the magnitude, I guess, the magnitude between those ones. And so what do we have? We have 4 minus 2 squared. And we're going to add to that 1 minus negative 3 squared. And we're going to add to that negative 1 minus negative 3, and we're going to square it. And so we have those different components. So what do we get up front? We get 2 squared plus 4 squared plus a 2 squared again, if we look at that working out. So what's d? D is the square root of 4 plus 16 plus 4. So the distance is the square root of 24, which they'll write as 2 root 6. And 2 root 6 will be the answer that they reflect in the back. So that's how you find the distances.